Okay, this last part about section 5 talks about absolute convergence, conditional convergence, and divergence. And no matter how they give the question to you, they may give it to you as an alternating series. They may give it to you like this. It doesn't matter how you see the original series. Like when they're asking this question, these two things are exactly the same. But you always, no matter how they give you the question, absolute convergent, conditionally convergent, or divergent, you start with the positives. What that means is the absolute values are convergent. So I'm going to start with the positives. I have the series 1 over n, not alternating, all positives. And we know that that diverges. That's the harmonic series. Okay, so if the first thing that you're testing diverges, you move to the second, which is alternating. So if I make this an alternating series, so even if they gave me the original problem like this, you would turn it into an alternating series for the second part. And I know that this converges because it meets all the requirements of the alternating series theorem. So we say that this series is conditionally convergent. It means that under the condition that the series is alternating, this will converge. Okay, so next one. Is this series absolutely, conditionally, or divergent? And they give me a series. And the first thing I'm going to do is run the absolute convergence test, which means I'm only going to look at the positives. So let's see, that's 1 over 1 squared, 1 over 2 squared, 1 over 3 squared. Well, that's just 1 over n squared, which is a p-series with p greater than 1. So these positives converge, which means that the series is absolutely convergent. You can struggle with this all the time. Then, let's see that. Okay, for this one, is this absolutely convergent, conditionally convergent, or divergent? They give it to me already with the positives. The absolute values are not convergent. This is a p-series. P is less than 1, so this is divergent. The positives diverge. Is it conditionally convergent? Well, if I make this series alternating, that's the first requirement, and that's what conditionally convergent is telling me to do. And the terms are getting smaller, and the terms are going to approach 0. So yeah, that converges. So this series is conditionally convergent. Done. Okay, so some homework help, and I only have one bit of homework help because a lot of these problems are just running one or more of these tests and understanding if you look at 1 over n, is the series going to have a value when we run the integral test? Well, no, it's not. Homework help. So the big one is a series will never converge because of the nth term test. A series can diverge because it fails the nth term test, which means that the terms are not approaching 0. But just because the terms are approaching 0, we can never say that the series converges. We have to run other tests before that. Okay, good luck with the Math Excel for this section.